What if a country quietly built the world's most powerful battery, one that never runs out, never needs the sun to shine, never waits for the wind to blow, and can power over 1 million homes forever? That's not science fiction. That's exactly what Canada is doing right now, 35 meters underground, and most of the world has absolutely no idea. Deep beneath the Darlington nuclear site on the shores of Lake Ontario, roughly 50 miles east of Toronto, Canada just achieved something no other G7 nation has ever done. A massive concrete and steel foundation, the beating heart of the world's first commercial small modular reactor, has been locked into place. And with that single milestone, Canada didn't just break ground on a power plant, it switched on the future of energy storage itself. Here's the secret the headlines are missing. Nuclear energy isn't just a power source. It's the world's only true permanent battery. Solar panels go dark when clouds roll in. Wind turbines stand still on calm days. But a nuclear reactor? It produces full, uninterrupted electricity for months between refueling cycles, 24 hours a day, 7 days a week, in any weather, any season, any condition. Grid engineers call this baseload generation. The rest of the world calls it the holy grail of clean energy, and Canada just built one. The reactor at Darlington is the GE Hitachi BWRX 300, a 300-megawatt boiling water reactor that is approximately 10% the size of a traditional nuclear plant, but every bit as powerful. Ontario Power Generation has contracted for 4 of these units at the same site. Once complete, the full fleet will generate 1,200 megawatts of electricity, enough to permanently power 1.2 million homes, continuously, without a single drop of fossil fuel. The economic shockwave from this project is staggering. According to the Conference Board of Canada, deploying and operating these 4 SMRs is projected to add $38.5 billion to Canada's GDP over 65 years. The construction alone is pulling in Canadian steel, Ontario concrete, and skilled tradespeople from across the province. The project team, combining Atkins Realis as architect-engineer, GE Hitachi as reactor technology provider, and Econ as construction manager, represents a made-in-Canada industrial powerhouse executing a first-of-its-kind mission. But why does this matter beyond Canada's borders? Because the entire world is watching and betting. Countries including the United Kingdom, Poland, Sweden, and dozens of other nations are evaluating the exact same BWRX 300 reactor design, specifically because Canada is building it first. The Darlington project is, in OPG's own words, the proving ground of the Western world for commercial SMR deployment. Every week Canada stays on schedule is a message sent to every energy minister on the planet. This technology works, it's buildable, and it's affordable. Compare that to the competition. The Tennessee Valley Authority in the United States selected the same BWRX 300 reactor for its Clinch River site, and won't produce a single watt until 2033 at the earliest. Canada's Darlington project targets first power by the end of 2030. That's 3 years ahead, despite the U.S. having the world's largest nuclear industry. And that lead didn't happen by accident. Ontario Power Generation spent years building the operational discipline that makes this possible. The Darlington refurbishment, a decade-long overhaul of 4 existing CANDU reactor units at the very same site, wrapped up in early 2026, 4 months ahead of schedule and $150 million under budget. In that same month, Bruce Power completed its Unit 3 major component replacement, also on budget and ahead of schedule. 2 massive nuclear projects, delivered on time, in the same month, while the rest of the world was still reading post-mortems on Vaudoul in Georgia, $17 billion over budget, and Flamanville in France, a decade behind schedule. OPG is carrying over 7,000 lessons learned from that refurbishment directly into the SMR build. That institutional knowledge is not just competitive advantage, it is Canada's $100 billion energy insurance policy. In April 2026, OPG submitted its application for a 20-year operating license for the first BWRX 300 to the Canadian Nuclear Safety Commission, filed while construction is already actively underway. That parallel sequencing is only possible because the CNSC's vendor design review for the BWRX 300 was completed years in advance. The regulatory groundwork began in December 2021. The construction license came in April 2025. Provincial approval followed in May 2025. And by spring 2026, the foundation was in the ground. This is not a plan. This is not a proposal. This is a building going up. OPG President and CEO Nicole Butcher said it clearly. This is truly a historic moment. This Made in Ontario project will support provincial companies, create jobs for Ontarians, and spur growth for our economy. And OPG isn't stopping here. Applications have already been submitted for the proposed Wesleyville Large Nuclear Project in Port Hope, Ontario, a site being evaluated for additional large-scale nuclear capacity on top of the SMR fleet. Ontario's electricity demand is projected to surge by 75% by 2050, driven by electric vehicles, data centers, industrial electrification, and population growth. The SMR fleet, the refurbished CANDU units committed to operation until 2055, and the Bruce Power generating station together form a nuclear electricity system that no other G7 country comes close to matching. GE Hitachi CEO Scott Strozich put the global stakes plainly. As we confront the challenges of increased demand, energy security, and carbon intensity, this milestone reaffirms our commitment to innovation and a more sustainable energy future. The BWRX 300's factory-built modular components are designed for replication at scale. Once Darlington proves the construction methodology, the cost profile, and the delivery timeline in a real commercial setting, every country watching, and they are all watching, gets a dramatically clearer, lower-risk pathway to build their own permanent battery. 35 meters below the surface at Darlington, the foundation is locked in. The reactor building is rising. The operating license application is filed. The G7's first commercial grid-scale small modular reactor is under active construction, on schedule, targeting first power in 2030. The world's energy storage problem may have just found its permanent solution, and Canada built it first.